Hi, this is Josh Fortier, and I want to welcome you to The Atom Part 2, where we're going to take a brief look at the history of some of the characters who helped us gain a better understanding of both atomic theory as well as atomic structure. First on our list is Antoine Lavoisier, born in 1743 through 1794. He was known as the father of modern chemistry. He was the first person to generate a list of different elements in his textbooks. He was best known, however, for the law of conservation of mass. Matter is neither created nor is destroyed, a very important thing for you guys to know. He also helped devise the metric system, a little fun fact. Now, when we look at the word elements, we aren't talking about what Aristotle referred to as elements in the first lecture, but what we mean by elements is this. These are elements made by atoms. So, it is a substance that is made up of one kind of atom, and it can't be broken down into simpler substances by physical or chemical means. Now let's look at the atomic theory. Even though Democritus was known to be the first person to theorize about the atom, it wasn't until about 1803 that our modern understanding of the atomic theory was clearly stated by John Dalton. All substances are made of atoms. Atoms of the same element are exactly alike, and atoms of different elements are different. Atoms join others to make new substances. Now, this term substance, actually what we mean by that is elements. However, this can also mean molecules made of more than one atom. Dalton was also able to calculate the atomic weight of many different elements, which will come into play later. It was J.J. Thomson that discovered atoms could be broken down into smaller particles. This allowed scientists to gain a better understanding of how different atoms interacted with each other. Thomson in 1875 conducted experiments using a cathode ray tube to demonstrate that atoms are made of negatively charged particles called electrons. This discovery helped him also to understand a better way in which atoms interacted with each other. But he also believed that the atom was primarily a neutral charge. This led to his what we call plum pudding model of the atom. So Thomson's plum pudding model looked something like this. Now, he believed that most of the atom was filled with this positive substance spread throughout the atom. More of a solid structure. You might even want to think, as an American, that this would be kind of like a cookie with chocolate chips scattered within it. Whereas the main part of the cookie is the positive part, and then these little speckles, the negative portions of the cookie, would be the chips. Now, in his version, he said that the electrons were speckled amongst these positive material like plums in a pudding. And this is where the name was derived. Now, in 1911, one of Thomson's students, Ernest Rutherford, began running some of his own experiments, and he called them the gold foil experiments. What he did was he discovered that the atom was not a solid structure at all the way through, that it was in fact mostly empty space and had a positively charged center called the nucleus. Now, the positive particles in the center, he named those protons, and he determined that Thomson's electrons must be found on the outside of this positively charged center. So he developed a new model where the middle contained a solid positively charged center with the electrons scattered around the outside, all still stationary. Now, as we continue our look at the evolution of our understanding of the atom, we come to Niels Bohr. In 1913, he proposed that electrons were not stationary, but traveled around the nucleus of the atom. He believed that they were stuck in definite pathways or orbits. However, he believed that they could jump from one path to another, This depended mostly on how much energy they had. So he developed this model, which is showing the electrons moving in what we call the orbital model. And often we use this in classrooms to kind of demonstrate how electrons might look. But it's not an accurate model that we really know that the atoms look like today. Well, Ernest Rutherford came into the picture in 1926. He made further discoveries as to the atom's nature in the way of electrons. The exact location of an electron cannot be determined, he said, and he believed it was more accurate to view them in regions called electron clouds. So if we look at his model, we will notice that the electrons aren't following the orbital pathway that had been previously believed, but they're going in many different directions, and actually they would change directions at times, and so it is impossible to predict where they would be. Now, we had many things still to learn about the atom. And that's why it was important that James Chadwick came along. Now, he was a colleague of Rutherford. Chadwick found that the mass, or the weight, of most of the elements were twice that of the number of protons, which at the time was believed to account for almost all of the atom's mass. This meant there was another particle that had not yet been discovered. In 1932, he made the discovery of the neutron. So what does this mean? It now means that in the center of the atom, the nucleus, we don't just have a positive structure that's solid. We have actually not one, but two subatomic particles, neutrons and protons. Which brings us now to our modern understanding of atomic structure. This also brings us to the end of part 2 of the atom. I hope to see you guys again for part 3, where we talk about how atoms actually interact with each other.